Hello dear learners. Today's discussion is significance of difference between means. What do you know about it? We were talking about arithmetic mean. Now we are talking about significance of difference between means. What is it actually? What is it? While there are data-based observations of difference between two groups, we are observing two groups based on certain data. Test of significance we can do and it will help us in predicting whether they could be due to chance, by chance or not. I have a set of data of boys, the same kind of variable I have measured of girls as well. I would like to compare whether there is a difference between boys and girls in a specific parameter. If there is a difference, whether it is by chance or it is significantly differing. This is actually significant differences between means, right? Let me read it again. While there is a data-based observations of the difference between the two groups, tests of significance help us to predict whether they could be due to chance. Further, when we talk about significant difference between means, Garrett in 1981 mentions it is a difference or a difference between means is called significant. According to Garrett, a difference is called significant when the probability is high and that it cannot be attributed to chance, that is, temporarily or accidental, and hence represent a true difference between population mean. For example, boys got their intelligence score and a mean of 113. Girls got an arithmetic mean. This is boys and their intelligence score. Girls got 115 as their mean score in their intelligence. We have tested. This is the mean scores, right? We have to compare whether the significance is true, statistically significant, the difference is significant. That is the concern. By looking into these two values, we can say that there is a difference. Girls have better mean score in intelligence. But actually, when you go for a testing, then only you can find out whether it is true significant, statistically proven significant or not. Peripherally, by looking into, you can say that it may be temporary or accidental, not by specific significance, not by significant concerns. This is actually significance between means. Again, when we look into a difference is non-significant when it appears reasonably certain that it could easily have arisen from sampling fluctuation and hence imply no real or true difference between population means. As I mentioned in the previous example, visibly there is a difference, but it is non-significant. I got it non-significant through statistical calculation. I have not given you an example of statistical calculation now, but I am giving you an example that is visibly it is significant, but it is not significant. When I go for a comparison, that is through a t-test, I got non-significant even though the values are 113 and 115 for boys and girls respectively. The difference value I got a t value is 1.11 or 1.101. This is my t value. Then I judge that the probability is greater than 0.05. That is, it is not significant. It is the difference between means of boys and girls is not significant. This non-significant measure or a difference comes when it appears reasonably certain that it could be easily have arisen from a sampling fluctuation and hence imply no real or true difference between population mean. Yes. Now in this context, we have to see null hypothesis. Certain terminology we have to learn when we talk about significant difference between means. One is null hypothesis. Null hypothesis generally asserts that there is no true difference between two population means and the difference found between the sample mean is therefore accidental or irrelevant. You got it? If you take the mean score of two different groups, say for example, for urban locality, I found 110 as the adjustment score of students. For the rural groups, I got it is 92. I've collected sample from 20 urban and 40 rural students. This is the concern. So, in order to test whether the difference is significant or not, I have to develop a null hypothesis. In the null hypothesis, what we mention is that the difference between two population means it is by chance, there is no difference. So, null hypothesis is mentioned as H underscore 0. This is this way we mention null hypothesis. That is, mean of the first category is equal to mean of the second category. This is the null hypothesis. Mean 1 is equal to mean 2. There is no difference between mean 1 and mean 2. Mean of the group 1 and arithmetic mean of the group 2, there is no difference. Yes, null hypothesis stated so that it can be tested later. Null hypothesis is a device that we take it for testing a hypothesis. Now, another term we have to understand as a part of understanding the significant difference between means is standard error. What is the standard error? Standard error is standard deviation of sampling distributions. It is standard deviation of sampling distributions. What actually standard error measures? It measures the error of sampling and error of measurement. There are two things, error of sampling and error of measurement. Standard error can be described as the standard deviation of all the standard deviations that have been computed for a given number of samples randomly drawn from a same population. From a same population, we can take hundreds of samples. For example, you got a higher secondary school students of Uttar Pradesh. This is your population. From the population, you have seen that 1000 is the population in Uttar Pradesh. So, you have to take 10% of this population as sample. So, people can take as many as samples of 100 number, right? Lots of sampling we can take it, lots of sampling varieties we can make it of 100 from the given 1000. So, when we go for the standard deviation of samples and all the standard deviation of various samples, when we go, this is actually the standard error. I told you it is standard deviation of sampling distributions. Lots of sampling distributions and their standard deviation will be taken. That is actually standard error. It is the error, it measures the error of sampling as well as the error of measurement, right? Now, another term that we have to understand is degrees of freedom. What is actually degrees of freedom? Degrees of freedom, yes, the number of values in a calculation that are free to vary, representing the number of independent pieces of information available to estimate a parameter. To estimate a parameter, it is mentioned as df. Df is the symbol that we mention for degrees of freedom. Short form we mention as df, right? In statistics, degrees of freedom is calculated as sample size minus one number of restrictions, such as estimated parameters are there, so we have to restrict one restriction. The concept is crucial for determining the validity of statistical tests. How do we do that? For example, in a layman's language, let me explain. For example, you have a parameter like a plus b plus c is equal to 100. Here, how many observations you have? 1, 2, 3, a plus b plus c. So, 3 is n is 3. So, when you go for a degrees of freedom, you can have the values of a and b, anything you can have, but one value, one restriction is there always to ensure the parameter, right? Ensure the condition, right? So, here 3 minus 1, 2 will be the degrees of freedom in this case. For example, a, you are taking a as 100, b as 200, but C you cannot write. C, there is restriction. What is restriction? 100 is the total. 100 is the total. So, you don't have a concern for, you don't have a freedom to write the third variable, to fix the third variable whatever you wish to. So, here what it is? So, it will be minus 200, right? So, that way we can mention degrees of freedom. Theoretically, when we talk about regarding the degrees of freedom, what is the degrees of freedom for a t-test? You know what is t-test? T-test, independent sample t-test, you are comparing two groups, right? Two groups based on certain variables. We have just mentioned intelligence of boys and girls. Two groups are being compared. So, here the degrees of freedom will be n minus 2. So, we have mentioned one restriction, then how it will be n minus 2. In the case of independent sample t-test, I just mentioned that it is n minus 2. In the example you have mentioned, it is calculated as the sample size minus the number of restriction, that is one number of restriction. So, how it will be 2 here? Because this n is n1 plus n2. The n is n1 plus n2, right? That is the total, that is the total n. So, we have two groups. So, either we can write the degrees of freedom of independent sample t-test is n minus 2, or you can write n1 minus 1 plus n2 minus 1. This is the way. In the case of one-way analysis of variance, one-way analysis of variance, again you have to go for, what is one-way analysis of variance? If you have more than two groups to compare, you have to go for one-way analysis of variance, one-way ANOVA or F-test. In the case of F-test, what is the degrees of freedom? For from every group we have to remove one, or we have to give one restriction. So, for example, I have three groups. So, total n minus number of groups, n minus k, total of participants in all the groups across the groups minus k. Otherwise, we can write from the group 1 n1 minus 1 plus n2 minus 1 plus n3 minus 1, like that. You can go this n1 minus 1 plus n2 minus 1 plus n3 minus 1. This is the degrees of freedom for a NEF test or for one-way analysis of variance. or we can mention as total n minus k. K is total number of groups. What about the chi-square? Chi-square. Chi-square, especially for a contingency table, it is row minus 1 into column minus 1, R minus 1 into C minus 1, row minus 1 into column minus 1, number of rows minus 1, number of columns minus 1, right? These are something I have to discuss about degrees of freedom. Do you get it? Yes. Again, read this. What is this? Let me read it again for you. When a statistics is used to estimate a parameter, the number of degrees of freedom available depends upon restriction placed upon the observations. 1 degrees of freedom is lost for each restriction imposed. That is why we have mentioned n minus 1, n1 minus 1 plus n2 minus 1, n1 minus 1 plus n2 minus 1 plus n3 minus 1 plus, like we were talking about in the case of ANOVA. C minus 1 into R minus 1, column minus 1 into row minus 1. So, everywhere we have one restriction, right? So, it varies with the nature of the population and restrictions imposed. We have seen the examples now, right? Now, another is levels of significance. What is levels of significance? Whether a difference between the means is to be taken as statistically significant or not, it is depend upon probability that the given difference could be arisen by chance. The serious concern, the researcher has to make a decision about which level of significance they are using to test their hypothesis. In social sciences, we generally go for 0.05 and 0.01 level of significance. 0.05 and 0.01 level of significance. It is also called as 95% of the confidence limit and 99% of the confidence limit. In social sciences, behavioral sciences, we use 95% of the confidence limit and 99% of the confidence limit. In some of the sciences, it will be 99.99. It happens, right? So, levels of significance is which level you are taking into account while you calculate and find out the level of significance which is. So, this is considered and to be decided by the researcher in advance which level you are going to take as level of significance. I have already mentioned for social sciences and behavioral sciences, we generally go for 0.05 level, that is 95% of the confidence limit, or 0.01, that is 99% of the confidence limit. For example, we were talking about the degrees of freedom, we were talking about the levels of significance. As an overview, I am just giving you how it is depicted in various tables. This is an example of a chi-square table. You know what is chi-square. Hope you have learned something about chi-square, otherwise you will be learning, right? See, it is mentioned the degrees of freedom here. As per the degrees of freedom, at which level I would like to take. This is in social sciences 0.05 and 0.01. These two are the levels that in social sciences we look into, 0.05 and 0.01. Certain cases see 0.001. Sharp sciences, they will look into natural sciences, physical sciences, they will look into the very significance at 0.001 level. 99.99% they will look into whether in that level it is significant or not. Got an idea about degrees of freedom. Now see, there are two types of tests when we talk about compare means and find out the significant difference between means. We have two types of test. One is one-tailed and the other is two-tailed test. What is and how we can mention that? One-tailed test is a statistical hypothesis testing system in which the alternative hypothesis specified such that only one direction of the possible distribution of value is considered. What about two-tailed? In a two-tailed test, alternative hypothesis is stated in such a way that it is included both the higher and at the lower level of values of a parameter than the value specified in the null hypothesis. In general, when we talk about the one-tailed and two-tailed test, there are two concerns for you. Two types of hypothesis we have. One is directional hypothesis. The other is non-directional hypothesis. Do you remember what are the difference between directional and non-directional? If I say that a strategy I developed is very significant in enhancing the achievement in mathematics. So my concern is that it is positively contributing to enhance the achievement in mathematics. The framework I developed and implemented as a module among higher secondary school students is beneficial to control unwanted anxiety of examinations. Suppose this is my hypothesis. These are directional hypotheses. Boys perform better than girls in sports. These are directional hypotheses. If you have a directional hypothesis, you have to go for a one-tailed test for sure. You have to go for a one-tailed test for sure. In certain cases, you write non-directional hypothesis as well. There is a significant difference between boys and girls in their performance. I didn't mention whether it is positive, whether boys better performers or girls are better performers. I didn't mention. I just mentioned that there is a significant difference between boys and girls in their performance. Such kind of hypotheses are non-directional hypotheses. So the requirement is two-tailed test of hypothesis. You got a clarity now? Why and how we select one-tailed or two-tailed testing, right? See some of the examples I've given. If it is one-tailed test, this will be the nature of hypothesis. One is greater, boys are better than someone, boys have greater emotional intelligence than girls, or we can say that boys have lesser language proficiency than girls. Such kind of hypothesis we are writing, they are directional hypothesis. You have to go for one-tailed test. Simply mention that there is a difference between these two. They are not equal. Just simply you mention that there is a difference, there is a relationship. In such a case, you have to go for two-tailed test as you don't have a direction in the hypothesis. So we go for a two-tailed test of hypothesis, right? This is an example is given like this. See, this is on one end only. We are taking on one end only in one-tailed test, but in the two-tailed test, both the ends will be taken care of, whether increasing, decreasing, we don't know, we are not sure about it. So we have mentioned a non-directional hypothesis. So the testing of hypothesis will be two-tailed test of hypothesis. Clear? Now, certain concern for us is different tests, parametric and non-parametric. What are parametric tests? Yes, those tests are more powerful. We call it as parametric test. The data should be normally distributed. They should be developed through a normally distributed, neat and clean data. Homogeneity of variance or homoscedasticity is to be ensured. Homogeneity of variance means if you are taking multiple samples, all the variances should be more or less equal. That idea is homogeneity of variance. Independence of variable, that is the variable measure should have independent existence. There should not be ranking or nominal data set. When you go for parametric test, certain conditions are there. Large sample is required. Large sample is concerned. In statistics, 30 is large sample. More than 30 is okay. We have to ensure the normality. We have to ensure the normality, that is second concern. And the third concern is, next is, the major variable should be measured either as interval or ratio. Nominal and ordinal will not be accepted for parametric test. Independent observation, everyone will have unique value. Homogeneity of variance, homoscedasticity. All these are to be ensured if you go for a parametric test. Large sample, normality, better selection of the sample, everything is a matter. When it is non-parametric test, these are less powerful and these are called as distribution-free statistics, distribution-free test. No assumption is required. It works on the principles of ranked data and nominal data. Ranked data is a concern, ranking. There is no other assumption of the powerful test are applied in the case. They are non-parametric test. This is a comparison, we have already mentioned it. For example, some of the distinct features we have discussed. This is for you to read, whether you know this or not. Just have a look into the video. The screen is mentioned, something about comparison between parametric and non-parametric tests. Now, let us compare different tests, which one is being used in certain cases. Now, let us come to different parametric and non-parametric tests, which can be used and at what level we can use it. Let's see some of the tests. I have already told you there are two kinds of tests, parametric and non-parametric. If you are comparing two groups, with all the conditions of a parametric test, the concern will be, the test will be independent sample t-test. Two groups are being compared and all the conditions of parametric test are fulfilled. Large sample, normality, the major variable is tested as interval or ratio. Similarly, sampling method should be random. Homoscedasticity, homogeneity of variance. If it is not fulfilled, you have a small sample, probability, you are doubtful about the normality, you are doubtful about the probability sampling, then you can go for a corresponding version, that is U-test, Mann-Whitney U-test. Now you are comparing two groups. For example, it is an experimental study. You have pre-test and post-test of a group. In the 6th standard, you have given a dialogue approach, dialogue-based approach for teaching social science. So initially, you are testing the students whether they are developing the capacity of critical thinking. So initially a test is being given. Next, through dialogue-based approach, you are teaching them. Now again at the end, you are checking their critical thinking again. So you have two tests of every students, pre-test and after the intervention, the dialogue method has been applied among them in the class. You have executed it in the class through lessons. Finally, you got another critical thinking test result with the same test that you have calculated their mean and standard deviation through the pre-test processes. Both the scores pre and post you have to compare. The test is paired sample t-test, paired sample t-test. I told you it is also called as related t-test, correlated t-test. If the sampling method, sample size normality, everything is doubtful, then you can go for Wilcoxon signed rank sum test. Wilcoxon signed rank test. This is an alternative. If you have more than two groups, you are comparing two groups t-test, more than two groups, you will go for one-way analysis of variance, and its alternative is Kruskal-Wallis test. It is H test. Kruskal-Wallis ANOVA is also a name for that. It is actually a kind of test that is used instead of one-way ANOVA. If you don't fulfill all the parameters and assumptions required for one-way ANOVA, but simply you have more than two groups, go for Kruskal-Wallis H test. If you have more than two related groups like repeated measures, pre-test, post-test, delayed post-test, what you have to use is repeated measures ANOVA, repeated measures ANOVA. So here, as a non-parametric version, you have to go for Friedman's test. You have to go for, as a non-parametric version, you have to go for Friedman test. So these are some of the things. When you are calculating a correlation or relationship between two variables, so it is a continuous variable and you are calculating both the variables are of same kind. If it is parametric, definitely the Pearson's product moment correlation will be doing. Otherwise, if it is non-parametric, the data is having a characteristics of non-parametric, you have to go for Spearman's rank correlation. One more correlation is possibility, that is Kendall-Stau. These are the possibilities for non-parametric categories of test. So this is all about compare means and significant difference between means. Lots of things we have discussed. What is actually significant difference between means? Contextually, we have seen different nomenclature when we discuss difference between means. Null hypothesis we have seen, standard error we have seen, one-tailed and two-tailed test we have discussed. Again, levels of significance, degrees of freedom, directional and non-directional hypothesis, parametric and non-parametric test. Could you remember? Yes. I hope that you have really achieved the learning outcome. Am I right? If I am wrong, that means you have not watched the video very specifically. Keep your copy with you. Pinpoint some of the very significant concerns related to each concept. Definitely you will be successful. I wish you all the success in your further learning. Thank you so much.